I'd like to introduce the panel Innovation at Speed, the new competitive mandate. This panel will explore how the United States can more rapidly transition groundbreaking research into real, fielded capability for the warfighter. Our panelists will examine the full innovation pipeline from early stage science and investment through engineering and integration and operational readiness, and discuss what must change to move faster in an increasingly competitive security environment. Moderating this panel is one of my mentors, General Hawk Carlisle, a retired four-star general whose career spans operational command, defense industry leadership, and policy innovation. He retired from the Air Force in 2017 as the commander of Air Combat Command, and following the Air Force, he served as president and CEO of the National Defense Industrial Association for nearly 5 years, strengthening collaboration across industry, government, and academia. Joining General Carlisle is Dr. Eric Evans, Director Emeritus of MIT Lincoln Laboratory, as the laboratory's 11th director. Dr. Evans expanded critical R&D mission areas, strengthened ties with MIT, and advanced technology transition to government and operational users. A trusted advisor to senior national security leaders, he has supported U.S. Strategic Command and the nation's nuclear laboratories, and previously led major programs in air and missile defense. His career reflects deep expertise in translating advanced research into fielded capability. Also joining the panel is Ms. Barbara Borgonovi, President of Naval Power at Raytheon, where she leads programs in integrated air and missile defense, advanced sensors, space systems, hypersonics, and effectors, including teams and operations based here in Tucson. She previously led corporate strategy and development for RTX and has held senior leadership roles across program management, operations, and engineering. Ms. Borgonovi also serves on the University of Arizona College of Engineering Dean's Advisory Board, strengthening the connection between local talent, industry leadership, and national security innovation. And our final panelist is Mr. Chris Moran, Vice President and General Manager of Lockheed Martin Ventures, the corporate venture capital arm of Lockheed Martin. In this role, he leads strategic investments in emerging technology companies that support Lockheed Martin's long-term business and national security objectives. Previously, he spent more than 3 decades at Applied Materials, including as head of corporate strategy and general manager of Applied Ventures, bringing deep expertise in scaling advanced technologies from innovation to enterprise impact. Chris is a graduate of the Massachusetts Institute of Technology, where he obtained his bachelor's and master's degree in mechanical engineering. General Carlisle, you have the chalk, sir.
Thank you, Tom. I really appreciate it. It's great to be here. I want to thank everyone for here. President Garamelli, Dr. Diaz de la Rubia, and my brother, General Rand. It's an honor to be part of this and be amongst this august crowd. I would like to start off with, I told the Kyle family a quick story, but I think it'd be valuable for the whole crowd. He is a great man and a great statesman. One of my jobs in the Air Force, job General Rand had, was legislative liaison, and I got to travel with congressional delegations, and I had a trip that was bipartisan, both House and Senate, where we went to the Middle East, and Senator Kyle was on that trip. We walked into a big event, tons of world media, tons of Coalition of the Willing, senior political leadership. And as we walked into the event, the entire Codel turned to go talk to the reporters and the media and the other political leaders, except Senator John Kyle. He turned around, went to the opposite direction, found the airmen, soldiers, sailors, Marines, and he spent his opening comments thanking them for their service and their sacrifice. So that tells you what kind of man Senator Kyle was. And again, it's an honor to be here and be part of this. And it's great to be part of the Kyle Institute for National Security, and I'm really excited. Now, I know that we are the only ones between you and a cocktail in the beginning of your weekend. So we promise we will make this an interesting panel. So the challenge that we're going to talk about, and we have great expertise here on this panel, to talk about how do you innovate faster, and our obligation as a nation is to get into the hands of the warfighters the greatest capability we can as quickly as we can. Our potential adversaries out there have some advantages. The four-letter word inside the Beltway, of course, is bureaucracy. Theirs is significantly less. They don't go through government shutdowns or continuing resolutions. But we have one, in my opinion, overriding advantage against every adversary out there, and that is the young women and men and what they do in uniform and swear oath to our Constitution, and our industry partners that are the most innovative in the world. So the question is, how do we do that? How do we really move this at speed? So I'm going to get right to some questions. We really want to give the audience an opportunity to ask some questions as well. But let me start with kind of the overriding one. And Chris, I'll start with you. All right. I'll direct it your way in the interest of getting as much as we can in this discussion. As we look to faster delivery, we're talking the requirements process going from 2 years to 90 days. How does industry evaluate risk as part of that? Because everybody says take risk, but that's a hard thing to do when you're talking taxpayer dollars. So that's a kind of a difficult question, yeah. But I start with one that gets to the heart of the matter.
So I wear two hats. I work for Lockheed, obviously, but I am their venture investor. So my job is to work in the world of risk, right? Everything I do is very risky. In fact, in the venture world in general, you can expect 90% of the companies to fail. And fail means they don't return investor capital. A lot of them go bankrupt, but usually you put in $1, you got less than $1 back out of it. That's failure on it. And so we're willing to take a lot of risk in that role because we're not putting a lot of capital at work. Generally, we're sharing the risk with other investors, right? We work with Raytheon on investments as well. It's generally, we call it a syndicate of 2, 3, 10 sometimes, or for big deals, but everyone's sharing a little piece of that. And so if the whole thing goes bankrupt, we only lost a little bit. So that allows us to spread the money around to lots and lots of companies, and we can see which ones are actually going to do well versus the ones that are going to fail. In fact, we've invested to date $500 million in venture capital right now, over 120 companies. About 10 have failed. About 30 are now solidly in our supply chain. About 10 more are emergent in our supply chain, which means they're in your supply chain eventually. But that's kind of the role, and that's kind of the way we look at it right now. Failure is acceptable, but measured and managed failure.
Any other comments?
Yeah, I'll add. What I would say is failure is acceptable, but we have to get to failure fast. And we also have to think about how we're going to test our capabilities as early as possible. One of the challenges we have is that we always are, and the industry, by the way, is doing it. As an engineer myself, I do it myself as well, always trying to get to the most exquisite capability. Speed has to be balanced with the requirements, and we have to have discussions as early as possible on what really is required. What problem, as a panelist said earlier today, Admiral Fallon, what problem are we trying to solve? And I think when we always say we're willing to give up on requirements, it's very hard to do in practice. So how do we develop early what really is required with understanding the trades with timelines? Not understanding just the trades to mission capabilities, but following it through to manufacturing and to speed. And I think we can do it. I think there are different ways to test early, to fail fast, and to learn from that process.
Yeah, and I agree with everything. And at Lincoln Laboratory, our mission was to take on high-risk, high-payoff projects and try to get something new to come out of that. And to take a major step, you've got to take on some risk, and the result of that is along the way you're going to fail. And we learned that we had to teach our staff how to recover from failure. Okay. And a lot of our projects were a series of small to medium failures that led to the ultimate success later on. And the recovery involved people coming together, maybe 6 to 8 people in a room, not 30, but a small number with a whiteboard, and they would say, now what do we do? And they would work together, not point fingers, but work together to figure out what the next steps would be. And over time, people learn how to work that way. And in many projects, the failure was a positive feature of the effort, not some impediment. And so it took a while for us to instill that mindset across a wide range of programs. But it's very important to take on those risks and manage failure.
Thank you. I was just at the Weapons and Tactics Conference up in Nellis, and both the chairman of the Joint Chiefs and the Chief Staff of the Air Force implored the folks out there to take risk, because we have to get inside of our adversaries' capability to field warfighter capabilities. So kind of in that same note, and I think this kind of brings into account a lot of what you're doing, is how do we make sure that early research, the 6.1, 6.2, and maybe even 6.3, that early research from places that have an exquisite capability, like here at the University of Arizona and the Kyle Institute, how do we make sure that we're addressing truly operational needs, vice just technology for technology's sake? Is there something more we can do to engage with universities and the national labs and the operational community to get at the most complex and challenging problems for the warfighters? Eric?
So, I mean, I think we have to be looking at how we can put people in the room earlier together. I think in earlier technology readiness discussions, we have to understand, again, the problem we're trying to solve together, but have technology roadmaps. And because we can't just, oftentimes we're trying to take something that was developed and put it in the end solution. That doesn't work when we're trying to shove it in. We need to be developing together solutions that have a purpose to solve a mission problem and to support the warfighter. So earlier collaboration and really bringing, I'd say, also the voice of our servicemen and women into the conversation as early as possible.
Yeah, we have this big building at Lockheed called the Skunk Works. You guys have heard of that, right? It's massive buildings in Palmdale, has no windows. Nobody can look out. Nobody looks outside. And that's kind of my job, is to run with scissors and try to get people to understand that there is a whole world of outside technology that moves very, very fast, faster probably than you move, than we move, than the services move. And it's to get that in front of the folks who can take that information and turn it into real value. And we try that every day, try to get these technologies in front of folks. So it's not working with universities, but you'd just be amazed how many people are out there now working on national security things, trying to provide product and capability to the services.
Yeah, we've had to grapple with this over the years with the prototyping work that we do. And in general, there's not enough overlap between the operational community and the technology community. And we had to very actively engage to do better with that. And so one approach was to begin developing the relationship with the forces deployed around the world. And for needs in Iraq and Afghanistan, we had special relationships with forces at the brigade and the battalion level, and we got lots of input about needs, and we could move quickly based on that. Another effort, and this was harder to set up than I expected, we set up a military fellows program at Lincoln, and in any given year, we'll have 40 to 50 military officers at the 05 and 06 level, many with recent operational experience, and they work side by side with the engineers and scientists in the prototyping efforts, and they really help us to get the initial condition better. And we get a lot of input along the way about it. It doesn't really work that way, the way we might use it out there. This is how you should think about that, and that's huge for us. And then the third area that's really helped is to get out and participate in the operational exercises. And many of the combatant commands will allow that to happen, to bring out some prototypes and try something new. And just that experience, you work side by side with the forces, they're testing some things as well, you get lots of direct input, and you really begin to understand how the technology might be used. So those three steps really helped us to do better with that.
Yeah, great answer. I think academia can take advantage of this as well. It's really a collaboration between the operational communities, academia, and industry, I think, to bring that all together. Back in the ATF days, Advanced Tactical Fighter days, we actually had a program called the Core Pilot Program, and there was 5 of us that were active in F-15s, F-16s, but we went out to the contractors, Lockheed Martin and Northrop, and we looked at different ways to put our operational expertise into the technicians that were brilliant but really didn't understand. I remember one question we had was, they asked us to find situational awareness. That's a tough definition when you think about it. You know, we came up with, you need to know what you need to know, but only what you need to know when you need to know it. So, but that's a bunch of fighter pilots, so you got to take it for what it's worth. Let's just talk a little bit about the recent history here and where we're at, and what engineering innovations, I'm really interested in personal opinions, that we're looking at today, whether it's automation, autonomous, semi-autonomous, AI. What are the engineering innovations that are coming about in today's age that you think will have the greatest impact on our ability to field capability to our warfighters sooner? Is there something that you're particularly interested in as you go forward?
I can start. So, of course, you know, the ones you mentioned, AI, absolutely. But I think some areas that we don't talk enough about, advanced materials. So when we think about hypersonics, for example, and the need to perform and the environmental factors, I think advanced materials are very critical for our technology development. Microelectronics and processing power. I think I can see probably hundreds of cell phones sitting on the table right now, and how do we take advantage of that processing power, especially in areas that wouldn't have had those capabilities previously. And then for us, you know, one of the big areas in my business, especially as you think about getting to speed, going back to the topic of how can we get the capability to the warfighter faster, because at Raytheon, there's no question about the level of our capabilities. You know, Standard Missile, Tomahawk, AIM-9X, all in my portfolio. We know that they perform, but you have to have the firepower in your arsenal to use them. So how do we replenish? How do we get that to the warfighter faster? Well, we need to manufacture faster, and in one of those areas is additive manufacturing. And how can we take a look at, you know, some of those big castings that we have to do for those missiles and use additive manufacturing to solve the problem of both lead time and capacity in the industry.
Yeah, I think it's, for me, and what our focus on is two things: time and tooling. How do we shorten the time to first article? We've made investments and work with companies that are doing Gen AI for engineering. You know, for example, we found one company that takes 90% of the time of designing a printed circuit board. Printed circuit board looks like the easiest technology in the world, but it's very complex, rife with errors, hard to produce. But we took 3 months out of a 4-month cycle already, and things like that. But tooling is probably a bigger problem, because tooling is how the defense industry builds scale, right? We're going to put billions of dollars into tooling. You're very familiar with the F-35. You've been to the factory. There's $4 billion of tooling, I think, but probably more, in that factory alone. And if you want to change something because a change came down, it's wildly expensive and time-consuming to do it. So how do we eliminate that? So we're looking at digital forming technologies for sheet metal, additive manufacturing, like you said, but a host of other things that we've seen just coming to the fore right now that can really shrink that time down. So if we can get really smart people to create new capability and produce it in months instead of years, that's how we're going to do it. And that has the added benefit of saving a lot of money to apply to other things that we probably need to do. All those things that need to get funded could probably get funded out of saving time and tooling and things that we do today, honestly.
I'll mention one area that is raised often, and that's digital engineering, which I think is very promising in many respects. But there are some cautions, and we had a Defense Science Board study on this a couple years ago, and the danger is to create a monster where you're integrating all the models, all the data, and there are all these processes to make sure all that happens in an exact way where it's burdensome to feed all that, and you want to keep it as lean as possible. The other part is there's still real testing that has to occur. So it's good to have a digital twin, but there are aspects of system design that are very nonlinear, and some of the physics are still unknown at some level, and real testing still has to occur and be integrated into the process. And so there's some recommendations around that in this report I mentioned, but there's a lot of good work underway, and there's some very promising benefits from it.
Excellent. So we have the benefit of the venture capital or the investment capital industry in the national lab in Lincoln and MIT. So in a place like this, which is incredibly valuable, the Kyle Institute for National Security, what would your recommendation be to an institute like Ken's in moving forward and becoming more of a team player, more productive and interactive with the department and with industry? I know that's a loaded question, but there's a lot to be done here. If you see the facilities and capability, but we need to get the most we possibly can out of it, and how do we do that?
Yeah, maybe I can start with that. I've had a lot of experiences over the years with this, and there are many models for technology transfer, and I'll just mention two, and how it can be made to work. One is a series development path where a university or a laboratory prototypes something new, and then a government program manager will have a competition or something to move it to industry. And that process at a high level is good, except there really has to be collaboration between industry and the universities and laboratories working together along the way. I found over the years, if you really want to make tech transfer not work, build something and then throw it over the wall. And so, for example, we've had a lot of good collaboration. I'll just mention one company, Lockheed Martin, with radar development. And with that, we would do some prototyping at Lincoln. We would have people from Lockheed Martin come and visit often to see what was underway. Very often, we would follow the hardware to the Lockheed Martin sites to make sure that they knew what they had and we could answer any questions. And it was a 2 or 3 year process. It wasn't a moment. And that engineer to engineer, scientist to scientist interaction was huge. Tech transfer is a very human kind of transition. And so it's important to set it up something like that. The other model, which is quite good, is a parallel path model, where very often a program manager can set up a high-risk, high-payoff path in a university or a lab, and then have a contractor taking on a medium-risk, medium-payoff path that will work for what the requirements are. And if the university or the laboratory succeeds, then the results go GFE, for free to the contractor. And there, of course, are a lot of benefits of that interaction I mentioned in the first model, and that has to occur over time. But that can work very well if the program manager sets it up in that way and then strongly encourages that engineer to engineer, scientist to scientist kind of interaction.
Yeah, and I'll just take a step back and say I would recommend aligning on strategic priorities and really spending the time early to say, what are we going to be focused on that has going to have the benefit? It's easy to want to do everything and to want to develop all the technology in a lot of thrust areas and different focus areas. It's very hard to do that well. So having that aligned, focused, strategic priorities with early interaction and a roadmap that you know is going to lead to results.
You know, I think that technology has a half-life, particularly today, database technology and so on. So the university shouldn't sit on it. You should move it out as rapidly as you can and let it sink or swim. I mean, the investment community that I'll speak for a little bit will validate it or not. I mean, if you don't raise money, maybe it's not such a great idea, and then go back, work on the next thing. But if it is, you can move that pretty quickly to scale to the folks that need it, whether it's the services or the primes or any of the other companies working with it. But don't sit on it. You got to move it out.
Yeah, great points. I think that, you know, we have to take advantage of everywhere we have incredible capability, and places like this, they actually have phenomenal capability, but it's making that connective tissue between industry, the government, the operators that are using it, and going back to we need technology that solves the most difficult problems for a warfighter. We don't need to jam technology into places. So we talk about speed. Part of this panel is how can we do this faster? I think Congress has done pretty well at giving us authorities. I'm not sure they've always been taken advantage of by the government. It certainly appears that this administration, this department at this time is really looking to take advantage of those. Is there, I guess, first of all, do you think we'll actually be able to increase the speed? I mean, that's a That's either, we will or we won't. And is there things that both the government and institutes like this can do to make sure that we take advantage and get to that speedier? You don't want to be fast to bad. Like you said, you got to fail fast. But you don't want to be fast to bad, but you want to be fast to understanding, I think, is the point. So any thoughts on whether we'll actually be able to increase the pace at which we're delivering capability to the warfighters?
Well, I was going to answer a slightly different question. I think the government's experimenting a lot right now, right? When I look at the contracts getting awarded to the small companies, there's a lot more than there were just a few years ago. I think the question will be is how then do we down select from those? I mean, those are essentially the tests. You're doing SBIRs, grants, OTAs, whatever. You're getting a lot of these companies spun up. They're very excited about it. But how are they going to scale if the larger contract doesn't come? And the government will do itself a disservice if it doesn't quickly make decisions. The venture world's used to failure. I mean, if they don't get the contract, it's going to work. They'll go on and do something new and come back at it again. But we're going to have to get the resources at some point to focus on the ones that look viable, that providing a capability, and then get them through the testing gauntlet, which I don't know a lot about in the defense space, but I hear about it all the time. That seems to be where things hold up, in just getting through the gauntlet of tests. You can design it, you can produce it, but getting it acceptable to that level is really, really hard and takes a long, long time right now. And that's an area that I think needs some innovation as well.
Yeah, totally agree with Chris. I would say, to answer your first question, yes, we will get faster, but it's going to be incredibly uncomfortable for the ride. I mean, we are going to be uncomfortable as industry, and also our government partners are going to be uncomfortable as well. And so getting through that and that cultural change is going to be hard for all of us, and we're going to have to challenge, because many of these programs, when I think about what we do here within the Raytheon portfolio for munitions in Tucson, we have incredible scale coming across so many of those programs. And they're decades old when they've evolved. The capability has evolved. They can take down new threats. They're not the same weapons that we built 10, 20, 30 years ago, but the foundation of these programs have been around for decades. So it's a long-standing institution that we have to challenge. And all of us are going to have to challenge that every single day. So it's going to be uncomfortable. It's going to be hard. We will make that change. And then to Chris's point, one of those biggest areas is how we test our products. We love to test every one of these products, especially when you think about a missile, as if you're doing a design verification test every single time. You vibe it, you put it through all the temperature extremes, you take days, if not weeks, to test it. Can we do that in an environment that's focused on speed? And more importantly, do we need to do that? And those are the questions that will be hard to answer, but we have to be brave to ask.
I think one other part on speed, though, I mean, there's speed of innovation and there's speed to scale. They're two completely different things. The way companies evaluate them, plan for them, budget for them are vastly, vastly different, and they have completely different dynamics. You're talking about this right now, how we do it, and that's why I said before that you have to limit your choices so that you can scale, because you can't scale 100 products or 100 things at the same time. You have to pick one, and the costs and so on that we have to deal with to do that are very different than the cost of innovation, where you're expecting risk. When you're trying to scale production, you're trying to design risk out as much as you possibly can.
Well, there have been some experiments, and I can mention one that works for technologies at some smaller scale, but we were very worried about the IED problem out in Iraq and Afghanistan, and the threat was changing every few weeks, every few months, and there had to be a different approach to counter that. So we tried something. We set up an approach where we would try to get funding in-house to put us on retainer to counter what was happening out there. So we got funding from the Joint IED Defeat Organization at the time, the Army REF, the Air Force RCO, and this was at the scale of maybe $25 to $30 million per year. And we'd have a very broad statement of work to develop technology to counter IEDs. And then we developed these close relationships with the operational forces on the ground in both countries, and we would get immediate feedback when something was happening. And we'd have a lean red team to extrapolate the threat, a lean blue team to figure out what to do about that. And when we had an idea, we'd talk to a government PM and say, we'd like to prototype this now. And within a day, we could start because the funding was already in-house. And so we could develop something over weeks or a couple of months. And then we had the path to send the prototypes out to theater. And that was a very important step because half of what we sent out there, the response we would get was, it was nice that you sent that, but what we really want is something else. Or the displays are too complicated, or the false alarm rate is too high. And we could iterate with them over days or weeks to get it right. And then when they were happy, we would transfer the prototype and 3 pages of requirements to a contractor base to begin working on it very, very quickly. And that way, within a matter of months, we could develop new technology, get it out in theater at scale, and get some good results. And we got very positive feedback on some of the ultimate technologies that went out there. Now, you wouldn't develop new aircraft that way, but you might develop new jamming techniques or new combat ID techniques or whatever in that way and rapidly get them out and get used and get the feedback.
Yeah, that's great, and I couldn't agree more. I think, the F-47 is going to take time, CCAs are going to take time, maybe the weapons or the electronic suites or those on it are ones that we can iterate faster and get to min-viable product and then move forward. On the side that you brought up, reference testing. There's an example that just came out of the conferences I was at WebTech where, AIM-9s and AIM-120s to shoot down $1,000 drones don't make a lot of sense, right? Because that cost imposition strategy we're losing. So we wanted, in some of our airplanes, we wanted to mount a weapon that was significantly lower cost, significantly higher magazine per airplane to give us more capability to counter small and medium UASs. The testing community said, great, we'll do that. It'll take about 2 years. And the answer was no, it won't take 2 years. And this is, again, the government's willing to step out. In fact, the Air Force said, no, it's not going to take it. We'll do the analytics, which we can do fairly quickly, and we'll put it on the airplane. We'll do a couple of test flights and a couple of launches and make sure everything's good, and we deployed it in theater. So I think those, the kind of speed is, and Chris and I had this discussion a little bit this morning, is not everything's going to be fast because you can't. That's just not feasible. But in the right place and the right time, you can go fast. And I think that's the talent and the art, because it's science and it's art. That's the art that the department and industry and academia, and again, I think a place like Carlisle Institute for National Security can be very key in helping direct this can go fast and we can make it fast, and then we can get it to scale in production. So with that, I think we are ready. We'd like to offer some audience questions. I think we are trying to get some feedback from the audience on the panel and what you think.
Got a question right here in the middle. Another one up front. We'll get the second microphone.
Hi, my name's Alex Evertson. I'm a cadet at the Detachment 20. And for all of us who are trying to become young, innovative leaders in the Air Force, what is something that you would use or say to us to inspire us to be innovative at faster speeds and knowing when to slow down to avoid major mistakes? Because there's a lot of things that we're being measured and evaluated on, and I think there's a lot of pressure when we're under the spotlight.
Well, I guess I'm probably one of the best people to answer that. So, yeah, so you're right. And I think, it's a great example is contracting officers. Contracting officers get evaluated on time, schedule, performance, and cost. So they're less willing to take risk in any one of those 3 areas, but to go fast, you need to take risk in all those areas. So I think it's more incumbent upon the Air Force to incentivize the behavior. And I will tell you, your current Chief of Staff of the Air Force, Cruiser Wilsbach, he believes that, and his intent is to take young, innovative leaders out there and encourage them to take risk. learn from it so you don't make mistakes again, and move fast. So I think from your perspective, from our young and all of our, by the way, congratulations to the debt here. You guys are fantastic. You got a lot to be proud of. But to take advantage of this opportunity to show, to put thought into it, to know what you're, that there is some level of risk, understand the level of risk you're taking, but then be willing to go out and go do it. And again, I believe that you're in an environment today with this United States Air Force and this time and this challenges that are going on throughout the world. Now is the time to take advantage of that innovative spirit and take risk. And again, you'll hear it from the highest levels of the certainly the department of, we got to take risk. It's the only way we're going to get there from here. So learn from them, understand the risk you are taking. I think those are the two things that are incumbent upon all of you, and then take advantage of the environment you're in today.
Piercer?
Thank you, State Senator Tim Dunn. First, I'm really honored as an Arizonan and as a Wildcat that my university would have formed the Carlisle Institute for National Security. This is really inspirational, and I think it's going to be pivoting Arizona ahead, and I thank the university for doing that. And the question would kind of apply to all panels, but what does the state of Arizona do? What can I do as a state senator? What can we do to make sure we foster and propel this synergy that we have with the University of Arizona, with the newly formed Space Commission, with the pending application for low orbit launches out of Yuma? What can we do to really make sure that this is the key place to foster this new partnerships going into the future with the state government as well?
I'd say definitely continue the support on the focus of talent in the region. Speaking on behalf of Raytheon here in Arizona, we will be continuing to grow. Many of the other companies in the region will be continuing to grow, and supporting that focus on having the right talent for us in the area, which the University of Arizona is a key partner for that on. I can't say enough good things. I moved to Arizona in 2024, and I've been on other boards and worked with other universities, but the U of A is a treasure, and we are thrilled with the partnership and the talent that we get from this university. But I'd say the people side of making sure that we have the right talent to support our business needs and the business needs of this region.
Fantastic.
There's three things that any venture capitalist looks for any company. It's talent, it's money, and market. So keep doing what you're doing, bring those things together, and great things are going to happen.
Another question?
I'll just add, I've been here for 2 days with various presentations and tours. Many of us have been on these tours. The talent here is exceptional. It's really great to see. And so maintaining that, enhancing that is a key part of continuing that success. The other part is to get out there. If you want to have an impact on national security, and I'm repeating myself a bit, but get out and listen to the combatant command needs and get some of the intelligence and understand it, and you'll be very motivated. Our threats are moving very, very quickly, and the nation needs talent like we have here to jump in and find some major improvements. And so you have so much here that is already running well. And I think there's some good next steps, and we're looking forward to seeing all that work.
Time for one more question.
Okay. Risk is really easy to say, but it's a really uncomfortable thing to do. And I thought about that from the perspective whether it's an individual doing something or from a company doing something and taking that risk. But the more you do it and practice it, it's a muscle, and you get better and you get more comfortable. Doesn't mean it's never uncomfortable, but you get better at doing it. And that was an important takeaway for me. The importance of the operator and industry integration and listening to one another to be able to find solutions faster. I think that priorities aren't just words. They can't be words. They really have to mean something, and they're going to guide both industry's investment decisions and where we think the future needs to be placed. So they should be thoughtful, but they should also be really well informed so that people can make long-term decisions off of them. And then finally, with that is that different perspective on test. That's another uncomfortable one that ties back to the beginning. We got to be okay being uncomfortable in testing some things and a lot of things failing, but finding the one diamond in the rough, if you will. So Dr. De La Rubia and President Garamella, I think you found another way for convergence and to bring three very different, diverse panels together and converge them in this National Security Forum. So please offer a round of applause to this panel as well as all of our panelists today. As they exit the stage, I'm going to invite my boss to come back to the stage and give us closing remarks. General Rand.
Let's see where we're at. Wow. You know, I was excited before I started this job today. I'm 10 times more excited than I was. Is that even possible? Senator Dunn, I want to answer your question if I may. That's why you have a KINS. We have this internal partners at the University of Arizona that are phenomenal through the provost, the deans, their faculty, their researchers, their scientists. And our job is to help facilitate those people with our external partners that you met many of them today, the federal government agencies and our industry partners, our members in Congress, to connect that. We are business development facilitators, high-speed cheerleaders, okay, so that we can help collectively bring solutions to those young men and women that are doing our nation's toughest job. Does that sound reasonable to everyone? That's what KINS is about. That's what the University of Arizona's research is about, is to help make our country better. And what a thrill. A few more thank yous and then we'll get you out of here. I would be remiss if I didn't ask the Kyle family to stand up one more time and we all give them, on behalf of their father and grandfather, a standing ovation. I sincerely hope that your dad is proud today. We sure are proud of him, and we're proud to have the name the Kyle Institute for National Security. We recognize our military leaders and members that are serving. That's really, at least for me, is personal, and that's why I'm here. We recognize our elected officials. Can I please, though, ask the provost and the deans and the faculty members and anyone associated within the guts and the bowels of the University of Arizona to please rise and be recognized. And then, you know, I always said this business that we're in, it takes three legs. It's like a bar stool. You know, when it comes to what we're doing in national security, it takes the government agency, skinny it down to warfighter. It takes our business industry partners, right? And it takes our Congress. It's a three-legged stool. There's challenges and there's blame to go around when there's challenges, particularly in acquisition and delivering capabilities to our nation. There's a lot of credit that needs to go around, and we need to give credit to those wonderful business industry partners that are with us today. Could you please rise and be recognized? If your industry, stand up. You're out there. Thank you. You know, I probably did it insufficiently, but it's humbling following Austin and the great organization that he put together, formerly known as the UARC, but now the KINS. This didn't happen overnight. It's been a 7-year journey. We have some of our KINS board members and we have some of our KINS teammates. Could I ask those associated with KINS to please rise? All right, almost done with thank yous. The last one, Tom Kunkel did a good job, didn't he? I don't think he slept for the last 2 weeks putting this together. I'm proud of you, man. Thanks, Tom. Lauren and Steph, from the amazing staff at ORP that you have, Dr. Diaz de la Rubia, and your team, would you guys stand so and raise your hands, Lauren and Steph? We want to see you back there. All right. The last thanks goes to each of you for your gift of time. From our university president, our elected officials, our senior military leaders, our business executives, every single one of you in the audience today, I'm keenly aware of your busy schedules and greatly appreciate that you carved out the last 4.5 hours with us today, so thank you. Allow me again to say what a tremendous honor it is to be here, not just to be a small part of the University of Arizona's inaugural National Security Forum, but to step into the role of President and CEO of the Kyle Institute for National Security. It's a humbling responsibility and one I take on with deep, deep respect for the legacy of Senator John Kyle and a clear-eyed commitment to the mission that lies ahead. You know, throughout his life, Senator Kyle was a statesman of uncommon principle, a leader who understood that national security is not just a matter of defense budgets or military asset, but it's a reflection of our values, our strategy, and our foresight. Today, as we dedicated this institute in his name, I would ask that you dedicate yourself to the enduring work of securing our nation in the incredible and increasingly difficult and complex world that we live in. Ladies and gentlemen, it's time for a wildcat reception. God bless you. Thank you. Rock on.